Hi there. So I hope you're having a good day so far. Today I wanted to go over Python instead of Houdini. I wanted to give a very brief introduction to Python just so you can have a very overall understanding of how Python is kind of working so that you're not super daunted by so much information all at once. And this is just built just to kind of get your feet wet. I've built several tools with Houdini specifically, and now I'm building Python tools in Unreal as well. So I definitely have a good handle on Python. I'm also the guy who built the library tool, kind of like recipes now. So I definitely have a good handle on UI and Python tools in general. So I am qualified to talk about this. So to get started with Houdini and Python, there's a couple of important things you want to keep in mind. You may want to have your console disabled and your external help browser turned on. Also, if you're having OpenGL problems, make sure to turn off the new Vulkan viewer. I had to for my Houdini. If you want to see something that you're printing out to test, you'll open up the Python shell either in a new window like this, or you can make a new Python shell by going here, clicking the plus icon, and Python shell. Now to get started, I want to go over one of the, really quickly, I want to go over a tool that I built that is really simple and it's really helpful. So I can just hit Ctrl Shift S and you can see my file name just versioned up to Python from Python 1 to Python 2. And that's with this snapshot tool. All it does is it saves and backs up your file, your current file. It increments the file name and then it saves it again because I like to have different versions. Super simple script, and this is just like something you can actually tie to a global hotkey, Ctrl Shift S, which is by default your save as, but I changed it to Alt Shift S because I don't use that ever. This is just an example of something you can build. You can also build a open up cache tool, or you can even build a flipbooking tool. You can show a versioning up your tools, all your file cache tools that you've selected. There's all kinds of things you can do with Python, from really quick scripts to really in-depth tools. Like the library tool that I built was really in-depth. So you can make UIs with tools. With Python source editor, when you edit stuff in here and you do whatever, and you hit accept and then you save your file, it's actually saving it into your file. So whenever you open up this file again, it'll automatically be executed. So that's something really important to keep in mind when you're working with Houdini Python, is to remember that you have something in here so that you're not messing a thing up. Now it's actually really good to use this Python source editor, I find. It's just you need to remember to delete it before you save your file. Otherwise you're gonna have it forever. The other thing I want to talk about is how modules work. So inside of your Houdini documents folder, you're likely not going to have a scripts folder. So you're going to want to make a new folder by hitting Control Shift N on a PC and saying scripts. You'll make another folder called Python, which I already have. Now these are my pipeline kind of configurations, which I may show at some point. But for now, we're just going to go into the Python folder. You're going to make one if you don't have it already. And then these are all your what are called modules go. Now modules are anything with it's a file with a .py at the end of it. And you initiate your modules with an init file, and that is __init __.py. And that is an initiation letting Houdini know that these are modules and you can import them in. It's just what you always have to do, and you can't forget to do it. So especially when you have folders, these are great. Now I never do anything with my inits. I don't find a need for them, but Python requires it. So make sure to put your inits in your file structure. Now regarding folders are a great way to keep your tools organized. If you have really complex tools, like this for example, does not need to be in its own folder. To be honest with you, it's perfectly fine just being out here, but I had it like this because I was planning on making a UI for it. Turns out I didn't need one, but I still have it anyway. into its own folder. You can choose to be super organized and always import your modules the same exact way, or you can choose to have some in the parent directory. It doesn't matter how you choose to do it. Just stay organized with however you choose to do it. So let's get started. So what is this import who? What in the world does that mean? So import is, it's letting Python know that we want to import in what's called a module. A module is, if we look at modules, you look at the documentation. Basically, a module is a file containing Python definitions and statements. So you can read this for yourself at this web page. You import in a module like this. So import.pfibo. If you look at the Houdini Python website and you look at this, something to look is where you put your Python script locations. This is a great web page to go to see how this stuff's working. I do not agree with this. I would use print, but okay. It tells you where to put your scripts here. Houdini path is typically in your documents folder like I showed. So it's under documents and then your Houdini version scripts Python. It's usually where it is. And then here's their startup scripts. This is the 456 I was talking about. So the 456 runs whenever a scene is loaded. So whenever you load up the scene, it just initiates whatever you have set up in the 456.python file. So anyway, so these are all modules and we can import them in like this. Import who. So these are what are called classes. And then these F, so C is for class, and then F is for function. And they're also called methods. So this is a function. It's a hom function. So I'm going to show you what a function is. So let's make our own function, and we're going to start with something simple, like so defined count up. Okay. Pass. So here's what we're doing. So def means define, count up, and then parentheses, and then colon. So in Python, you do colons and you have to indent everything. So def count up, and then we're gonna say, we're gonna feed in a number, and then we're gonna say plus equals 1. And then what we're gonna do is we're gonna return, meaning output, give me an output of x, the new number x. So if we say count up 2 or 3, and we say like t is this, and then we print, which means show it to me in the in this console here. We hit apply, we now get 4. So what we've done is we've made a function called count up. We've given it, let me make this more clear, number. And then t is just a random variable I'm making called t. And we're just saying equals count up 3. So that means, what would we expect? If we say count up 3, we're going to expect it to go up 1 and then return that number. T equals, because we're saying return, we're expecting an output from this function, and then we're getting t and 4. Okay, that's a very simple function. Now let me show you what a default argument is. So this is called an argument. Anything inside the parentheses, when you're initializing the function, is called an argument. So there are required arguments, which in this case, this number is a required argument. And then there are default arguments. So a default argument is, let's just call it default equals 3. That is initialized the moment we set up this function. That variable only lives within this function. These variables only live within this function. And it's pre-initialized with this number 3. And it's designated now as an int. So integer. So that's not required. So if we execute this, let me quickly do this. It's still going to work, even though there's an additional argument in here. If you say plus equals 1. You can do this, and then you can print default if you wish, just to show you. Let's give it a different number. So now 6 and 4. I just wanted to point out that there are differences. So like, for example, the tool utils find child node of type. The parent node is required, the node type is required, but these next two are not required. However, you can modify them to change how the function operates if you wish. So that was just a distinction I wanted to point out. It is important to know, and when you're coding more complex things, default values inside of functions actually come in really handy. So wanted to point that out. Now let me show you what a class, let's build up on this. So this is a function. Now let me show you what a class is. So who is a module, but inside of it they have classes. Let me show you what that means. This who op node is a class. You can see here class. The base class for all nodes in Houdini, an instance for this class, blah, blah, blah. I'm going to show you kind of what this means. In Python, to define a class, so again, this is a high level overview of how to do Python in Houdini. So if we make a class inside of here, we can say class animal. You literally just say class. Then you define what's called the init. So the same way I showed you before with the init here, the file, we are initializing this class, and we're going to call the class self, which means every function, every attribute we give, like in Houdini, every attribute we give it, the name we should reference for itself is going to be self. And this is just a convention for classes. You normally want to say self. So this is just kind of how you do it. This looks complicated, but again, this is just a very high overview. I'm not trying to scare anybody. This is just an overview. So we can give this animal attributes like can speak, and we can say 0 or false. You can also say false, same thing. They equate to the same thing, basically. You can say can walk, and that'll be 0. Can be multicolored. You can say 1. So we just did it. We've made a class called animal. We've initialized it with some attributes. Now let me show you what inheritance is. So inheritance, we can make another class. We can call it dog. Now the difference between dog and animal is I'm going to do parentheses this time. We could have also just done it with this, I think. But to make sure this works, I'm just going to do it the same way I did it before. And we can inherit from animal. So animal is the parent class, and then you can have a subclass, kind of like how object node is inheriting op node. Op node is inheriting who node. Dog is now inheriting from animal. And then the way we do this is we say it's a little bit different. So now we say define init self, same way we did it before. But the next difference is that we're going to say, instead of just immediately starting to do it, there's a technicality here, and you can ignore this because it's not really important, but just to show you, again, what we're talking about here is you have to type out this. Now, you can forget about this. This is just high level. I'm just teaching you high level stuff here. So to inherit the attributes we're inheriting from animal, like these guys, these attributes, you have to actually say super. And that's because whenever you define the init in a subclass, it actually overrides. So this is like a blank slate. So if we don't have this line here, it's actually like a blank slate, and it's getting rid of the previous init we had here. So we want to make sure we have this here so that it's basically copying everything we had for the animal, but it's putting it in here with this one line. And so now we don't have to type every single one of these out again. And even the functions too. If we had functions in here, like walk, say, and we had something, we could inherit all those functions and attributes with this one line. So what we're going to say is we're going to say self can bark, and we're going to say yes. So it has all these attributes, and now it has an additional attribute called can bark. So what can we do with that? Well, we can actually print and, well, yeah, let's just start with the attributes first, and then I'll show you. Let me get rid of this. I don't want to complicate it. So let's initialize the class. We'll say dog1 is dog, like that. Let's make sure this works. It does. Now I want to print, again, to this console, dog1 can bark. Let's see, can it bark? Yes, it can. It printed out 1. We're printing out that attribute can bark. Now I want to see, can it walk? Did this inheritance actually work? Yes, it worked. It cannot walk. I mean, it can walk, just not on 2 legs. Great, so I've shown you inheritance. I've shown you kind of like how inheritance works between 2 different classes. And then I also want to show you functions. So within a class, you can have functions. So we can say bark, and then you have to give it the name that you initialized it with. So that's self. When you define a function within a class, it's a little bit more complicated. So in this bark function, you can say pass just to make sure there's no typos or errors. Pass is just skip. So skip this line, or skip, it's just like a failsafe. So bark, we're gonna say print bark bark. Okay, we're gonna print can walk, but then we can actually call the function that we just defined up here by just saying dot bark. Dog is the class, bark is the function. So to show you, it would be dark.bark. Dog.bark. That is the how you initialize the function within this class. However, because we call this is an instance. Dog1 is an instance of this class. We now need to say dog1 can walk, or dog1.bark, since this is an instance and this is the name of the variable we defined earlier. So let's let it bark. Bark bark. Cannot walk. And we now have a function called bark bark. So this is a very high overview of kind of how classes work and functions within classes. This is awesome. Now you can kind of have a good overview of, okay, this is what all these guys are doing. So this is a function and it returns the parameter of the given path. That's that. So this is just a really high overview of what you can do. And now I'm just going to go over in general how to do stuff. One thing that I should have mentioned that I did not mention is that classes inside of Houdini, and usually, pretty much always that I've seen, classes are capitalized. They are, I think it's called camel case. So camel case is where the first word starts with either case, and then the following words have an initial uppercase letter. So yeah, functions start with a lowercase letter, and then classes are an uppercase letter. That's basically the easiest way to distinguish between classes and functions. So it just goes to show the way that I was doing my classes before is not the normal way that productions do it. So just in case, hopefully that clears up any confusion about my class names. I was not doing it to code. So before we continue, I want to go over configuring vscode so that you will have autocomplete for the Who module, so that whenever you type things like this, it'll actually autocomplete. This is really handy because it gives you the help for that function, things like that. What I found is that you can really just go to View Command Pilot and say Open Workspace Settings, and you'll see the JSON version. And this will create a folder .vscode along with the settings.json file that you will edit. Now, if you for some reason don't see these things in here, you can always manually go to where this place lives by right-clicking on one of your modules and say Reveal in File Explorer, and then you can say Ctrl-Shift-N and vscode, and then inside of here you can create your own settings.json file, and it will live here and it will live update. So now you need this, And now you just need to type out string and then a thing and then a comma. So we're just going to say Python analysis extra paths. And oh, it already completes it for me. So here you're going to want your install directory. I'm just going to show you what it looks like. So it's going to come in like that. We don't want that. So what you can do is just select the first guy and hit Ctrl D, and that'll select the next available entry that you have selected, and you just keep pressing that until you selected all of them, and you're just going to hit /. That's one of the hotkeys while we're here, and you just hit save, and then now when you come in here, your Houdini now will work. So agent whatever, it'll now work, which is awesome. That's what we wanted. You can also set the default Python interpreter, but you'll need a comma. You can say Python default interpreter path, and then here you can put your, it's under Python 3.3, and then this guy, this is the guy you want, and then again we're gonna say here Control D to replace all of them, and then we're gonna say Python 311.exe. I think that's the one. 3.11.exe. Yeah. So we can also do this. So this is gonna set it up for just your project, and this only works when you say open folder. So whenever you go into your documents, scripts, Python, and open this folder, this will open up this workspace. So this VS Code settings is only for this particular workspace, which is typically fine because all your Houdini scripts are going to live here. So it's fine, and it'll carry through all the rest of your tools as well. So that's great. All right, so let's start by actually making our first module. So the way I'm going to do it is I'm going to go into my Python folder, and I'm going to make a new text document, and we're going to delete everything, and we're going to say, let's just say hello .py. Yes, I want to change the extension. So by default, we already have the init. If you don't have that created, go ahead and create that using new text document and just creating that and renaming the file to .py. And what we can do is I'm actually going to go ahead and go back into my workspace here. Just going to open it up, and hello, and we're going to say import who, and let's go ahead, let's just say print hello. Okay, so let's just do this. Let's just do our very first module, and the way I'm going to do that is I have my own shelf here, and I'm just going to say new tool, and by default it's going to go into your default shelf. And if you want to make your own shelf, it's probably ideal that way, because your default shelf can get corrupted. So I like to make my own shelf so that it won't get corrupted, or if you update your preferences, whatever, it won't mess anything up. And this is another reason actually why it's a good idea to save your Python scripts in an actual file or module instead of writing it in the shelf, is because your shelf can get corrupted and it's not fun. So it's a good idea to get shelves, but it's an even better idea to make your own shelf, and it's an even better idea to make your own Python modules external. So we're going to call this hello and hello, because it doesn't matter, we're just doing this. So we've made our first, the name has to be lowercase and it cannot have spaces in it, because I actually ran into this problem in production one time. I was making a tool and then realized, oh, my name's has a space in it. You cannot have a space in the name. Do not do that. Make sure it's underscore. And the label can have spaces, so you can say hello, friend, whatever. That can have spaces, that's fine, because it's a label, it's fine. So make sure if you're in production, you're writing tools, make sure you don't have underscore, make sure you don't have spaces. So we're going to say this, and we are going to load up the module. So what do we call it? We called it hello. So let's import in hello. All right, we've imported it in. Let's make sure it works. I didn't see any errors. Import hello. Now that's not going to do anything because you can't just import it. You need to reload it. So there's a module after I think 3.5, whatever, Python version 3.5, whatever it was. They made it difficult to reload it. So you just be able to say hello. Now you have to say import lib, and then you have to say import lib.reload for your hello. And this will actually initialize your script, your module. It'll actually initialize it, so like execute it. Now, usually you don't want that to happen. You don't want to have code in here that automatically executes the moment you load it, you reload it. That's usually not a great idea because you want to have explicit control over how your code is executing. So a better way to do this is to write functions inside your module that you'll then reference inside your shelf tool. So I wouldn't put hello in here. I would make a function inside my module, print hello, that I would then reference. Now when I reload it, nothing happens. And here's the thing that's great about modules that are on disk is that you can code in your external editor. I prefer vscode because it's amazing. I used to use, what is it, PyTorch, PyCharm. I used to use PyCharm and found it was good, but it's only good for Python. If you're doing anything else, it's anyway. This is great. I have a lot of hotkeys I want to show you guys. I'll go into it a little bit later. So we reloaded the module. Any change you do to this now will automatically reload. If you did not have this line in here, you would have to restart Houdini just to see any changes that you did to your module. And that's a huge pain in the butt. So it's a great idea to have an external editor and then reload your modules so that you can get live updates. So this is a great way to do it. So we're reloading the module, and so now that function should be accessible within our tool here, our shelf tool. So the function was called print hello. So let's just print hello. Sorry, we can't say that. We have to say hello.print hello. And it is a function, and it doesn't require any arguments. So we're just going to say print hello. And then you have to run it. And we have just called our first module, and we've made a function out of it. And that's awesome. All right, so let's actually begin writing out the tool. So we need the Who module, obviously. And we also need a different module called the tool utils, which looks like this. Now, interesting thing about tool utils is it's an external module that I wish I knew about way earlier. So this is why I'm telling you guys about it now. It is extremely useful. It's got a host of really useful tools to it. You should study it when you get the chance. And it lives, if you just look up tool utils Houdini, it lives on this really nice GitHub pages. Documentation isn't all that great, but it's still pretty useful. Like I wish you can collapse these, but you can't. So it's got like a couple really great things. There's a network editor you can get. Network editor. It returns an existing open network editor pane if there is one. I use this all the time in my nodes. and then also node type name base. Let's just dive right in. I'm going to show you guys a little bit later how it works, but let's just dive right in for now. We've imported our who, imported our tool details, and let's just get started. So what do we want to do? Well, we want to first activate this function when we run the shelf tool. So let's go ahead and copy this function name, and we're going to just say, instead of print hello, so let's run this. Okay, cool. And now we don't have to keep opening up that tool. Now we can say printing pipe, like whatever. And you just run it again, and there it is. So now we can see kind of what's happening. And we could even put both of these guys side by side, and this way everything will just kind of work. So you can cut this Explorer window off, and now we have both of them side by side. So what do we want? Well, first, we actually do want the network editor. So what is the network editor? How do we get the network editor? The easiest way to get the network editor is with the tool utils function. It actually has a network editor built into it. And you can kind of see when you hover over it, you can kind of see all the different things you can do. It's really great. You can just see there's a network editor and then there's a scene viewer, which is really handy too. We're going to say network editor. And what I like to do is say NE. I like this to be my network editor because it's really easy to access later, short and sweet. And to get rid of a line or multiply selected lines, you can hit Ctrl and then the question mark key. I don't know if that's a forward slash or a backslash. It will comment out the currently selected lines. To get rid of lines, completely deleting them, that's Ctrl-Shift-K. That'll delete lines. So that's a really handy one. Another really handy one is, let's say we want the this line to go above the print line. We can hit Alt and then arrow key, and that'll move it all the way up. We can see what's happening. And you can even do that with multiple lines, I think. Yes, you can. See what's happening here. So this is a really useful one. And then another extremely useful one is Shift-Alt down will actually duplicate a line. And then you can even move that line. Like all without leaving your keyboard. It's great. So let's uncomment that out. And now we have our network editor. And what that returns, let's actually go to this, and we'll actually, since it belongs to, it's a class, so this function is buried in the tool utils module, and this function returns an instance of this class, network editor. It has a bunch of useful stuff like cursor position. You can get selections, decorations, all kinds of things. It's really useful. But in our case, we're gonna use it later. So I'm actually gonna get rid of this completely. Ctrl-Shift-K. Let's get the currently selected nodes. So who selected nodes 0, and then first item. So let's look and see what this is. So selected nodes. So this is a tool I use extremely often. This is a function that's built into the who module, and it returns a list of all selected nodes, and you can see what it returns. So this arrow means that it's returning this. So it is a tuple, which is basically like a list, kind of, sorta, of who.op node. So let's look at that. We'll middle mouse or control click on this link to open up in a new tab, and you can see. Now, previously in like Houdini 19, this was just called who node, and now they've changed it to op node as to differentiate between the two different classes, because now there's a few other classes you can do. Like Apex. Okay, apparently that's why they did it, so they can add Apex to it. But getting the selected nodes will just return this selected node if it's there. So we got the selected node. Let's print node There it is, attribute wrangle 5. If we do this, attribute wrangle 2. Okay, we have the currently selected node. Now let's see what happens if I print nodes and you can see what happens. It prints out parentheses here, means it's a tuple. And it is a tuple of one node, just one node, and it's telling you the type and it's telling you the path to that node. This is just typical, like how it prints out if it's a list of nodes. So we only need the first node because that's all we really care about. And you can modify this later to be more nodes if you wish. So before we continue, I do need to point out what this means, this bracket with a number. So this is returning a tuple, but you can basically think of it as an array or a list. And arrays and lists, they look like this. So 1, 2, 3, 4, 5. And if you want to get the first index, what's called an index, so the positions of each number inside the array is what's called an index. So arrays in most programming languages start with the index of 0. So this will be the position or index of 0. This will be the position or index of 1, and so on. And so when we say bracket 0, what we're saying is give me the first index or first position of this array or tuple or list. It would return 1 in that case. We're just going to get the first node because that's typically what you're going to use this tool for. And then we're going to get the type. So we're going to see, okay, well, what type is this? If we want to select all by this type, how do we determine like what type is this? And just to show you what I mean, I'm just going to drag this in here, hit enter, and I'm going to say type. What does this print out? Well, this is, I can't type this in Python, so I need the name of the type. So n.type.name, and that gives me attribute wrangle. And I believe this actually gives me the node type name base if I give it a node, and this is actually really useful. So we can actually use this instead of what I have written down here. So we can actually say node type is toolutils node base type name base, and you can just arrow down. So if you see an autocorrect that you like and you want to arrow down, you can just arrow down, hit enter, and then I'll select it. So here we need to provide the node. So this is a required function and it returns the node type, descriptive namespace, or version. So we need this node type, and I think this gives you, wait, let me see it again. Base names. This is the name, so this is node type. And if we do this, it'll say attribute wrangle, so okay. However, if you want to get the exact node type, we really need to do node and then type and then name. So when you look at the op node, there's a type, node type. So when you say type on a node, like right here, this is going to return a node type. And then you can take this return value that you've returned at the end of this function and feed it directly into a new function. So if we didn't do this, we could just say name is equal to node type name. It's the same thing, it's just shorter to say .name, and you can say name here. And next what we want to do is we want to get the parent of this particular node. So what is the parent? Because we're trying to find the children of all the nodes within the parent of this node. The reason for this is because basically what we're going to do is we're going to go here and then search within this node for all the children.
inside of it. So let's go ahead and do that. I'm gonna say parent is equal to node.parent. So if you look at the, hopefully, oh yeah, we'll go up here and we'll go here and we'll say parent. See how nice this documentation is? So parent, it returns who node. Returns the node that contains this item. So if you have something selected, it's going to return the obj and then it's going to return go1. So let's do cell nodes for selected nodes is equal to tool utils, and this is where that tool utils comes in. And we're going to say find all type, and it'll autocorrect to find all child nodes of type. So find all children nodes of type, and it needs the parent node. So we're going to feed it the parent node, and that is parent. It needs the node type, and then we're going to feed it node type name. And I just hit enter there to autocomplete, and then do recurse. Meaning, do you want to go inside of those nodes, or do you want to just do the top level nodes? So we just want to do top level nodes, only the immediate children inside of Go1. So we're just going to do that, and then cool, we got that, and then we have those nodes. So now let's actually, so this isn't going to select the nodes, it's only going to return them to you as a list. So see, now this bracket means that it's a list instead of a tuple. There are minor differences. You're welcome to look it up. So we're going to delete this because we know what it is. And I'm going to say for in cell nodes in set selected. And we're going to say 1. So what is this? What did I just write? This is a for loop. So inside of Python, you can do what are called for loops, and you start them with for blank in blank, x in y, and you do a colon, and then you hit enter, and then now vscode will automatically tab for you. And you see this error, and that's because we have to say pass. We can't leave a for loop empty. Like I talked about earlier, you can't leave it empty. And this y is here because this y is not initialized yet. We have to initialize it. Now I'm not worried about this. I'm just showing you. So shift down, Control Shift K, delete, and there you go. Here we're just selecting all the nodes with a for loop. And I'm going to Shift Tab to go back one. And then finally, we got this network editor for reasons. Let's use it. So the network editor has a really great function called frame selection. This isn't working because you haven't ran this, so this is technically not executed yet, so Python doesn't know what this is yet. That's why it's not working. Okay, so ini.frameSelection, and this will frame the selection in your network editor, which is really handy. So if I come over here and now I have all these transforms and I hit hello, it'll now frame those selections. It just makes sure that it's within the rectangle. It doesn't have to be zoomed in or anything. It just makes sure it's within the rectangle. And that's it. We've made our first tool.
All right, so we've made our first tool, the select all by type. Now let's experiment with getting a new tool, and let's just call it create nodes. So let's create a series of nodes all inside of Houdini. Let's do that with def. We'll make a new function that'll do this, and let's say it's called create nodes. All right, and we'll just say creating nodes just to test it, just to make sure it works. When we modify this shelf tool, you'll have to delete the previous one and just say create nodes here instead. Hit accept. The way this is going to work is we have our created nodes. Let's actually do something a little bit more interesting. We can actually move, let's go all the way up here, and we can actually move this guy way up here because we're going to need him later. So now that we have that, we don't have to worry about the network editor later. It is known as a global variable that you can access at any point since it's outside the what's called a scope of the function. So it should be a global variable that you can access. So we're going to say, we already have any, so the current node, or where I'll show you what I mean. So a good way to see what a function does or how to access stuff, editor, and then you can hit dot, and you can see the stuff you want to access for that class. So if this isn't initialized for some reason, you can always who.network editor and see what options you have. So there's a PWD, which is the workspace directory. I learned this when I was building my library tool, and it's extremely helpful. So what it returns, there's another node called, there's the any current node, and this is different. The current node, if you have a wrangle in here, the current node is, even if it's not selected, if it's in your parameters window, it's going to act like this. It's going to return the attribute wrangle 1 node. So the PWE is going to return the Geo1, so where you are in the network editor actually, like so this path. Okay, the current node returns if you've previously selected a node or it's highlighted in your parameters window, it's going to give you return that node. So it will return the attribute wrangle 1. That's the difference between current node and PWD. So what we want is we want the current node. So where are we in the network? Because you don't want to just create anywhere, because you might be in a subnet too. You want to be able to create nodes inside of here as well. You don't want it tied to a specific thing. What is the parent where we are currently in the network? So we have this current node, and just in case there's anything else that is selected already, we can clear that selection. So let's say ne clear all selected. That's what that function is. And again, network editor clear, there's a clear all selected, so you can see how it came about that function. You can also control click on a function to go to it in VS Code. So you can actually see where it is on disk, and we can do the same thing with tool utils actually, which is super handy to see where stuff is. And now this, you have to set up your VS Code to do that, which is what I went through earlier. But anyway, so let's clear all selected. Let's delete this line. And then we're gonna say the object level is current node. So just to say this is where I wanna reference my parent. This is what I'm gonna call my parent. What do we wanna do? We wanna create a bunch of nodes all at once. So how do we do that? Well, we can do that. If you want, like, let's say you want 4 wrangles, you would say there's a range which returns a number. When you're running it through a for loop, it returns a number from 0 to that number. So if you say for I in range 5, it will return 0 through 4 in this case. Now I'm doing tests here to show you. So for I in range 1 through 6, it will print 1 through 5. Now if you look here, it actually explains what happens. So returns an object that produces a sequence of integers from start inclusive to stop exclusive by step. So it's start, stop, and then step. So this is going to be, the first one will be 0, 1, 2, 3, 4, and then it's going to stop there. If you were to say 2, it's like an integer, so it rounds down. So if you say 2, it'll be 0, 2, 4, and then that's it. It won't continue. You can also say -1 to go backwards. So that's that. That's how that works. So it's by default the start is 0. So if you say in range 5, that means you're going to end up getting 5 total. Because see, 0 to 6, 1, 2, it's 1, 2, 3, 4, 5, 6. So if you want 5 total, you're going to say 5 here. If you want your numbers to start at 1 and end at 5, then you'll say this to do up to 5. So 1, 2, 3, 4, 5. Okay, great. That's great. Let's create the node. So wrangle is equal to object create node. So this is how you create nodes inside of a wrangle. So first you need your parent node, and then you're gonna, the way it works is you provide the parent node, which is object, and then you tell that to create the node for you. So it's like this. You have your op node, and then you say create node, and it creates a new node of type node type name as a child of this node. So that's what that does, and you can read the different arguments here, and you can click on it. Sometimes they give you pretty good, yeah, here you go. You can get pretty good explanations for what's going on. And so we need to specify a type. So I already know what kind of type I want, and that's attribute wrangle. And a good way to tell what it is if you just drag it in here, hit N, and then say type name, and it's attribute wrangle. So you can just copy this and put it in here. Copy by double clicking, right click, copy, and then just Ctrl V to paste. So it's gonna create 5 nodes, and that's great. So let's save that and run it, see what happens. All right, we clicked it and nothing seemed to happen. If I hit F though, you'll see what happens is it likes to create it in the center of the object, or the pane that you're in. So all of them are on top of each other. They're not neat, and they're all just kind of scrambled. So let's remedy that. I'm gonna clear my network. The way you get nodes to be in a good position is by saying, once you have reference to this node, we can say wrangle.move to good position. And I'm going to show you what that does. So who node move to good position, and it tells you what it does. Moves the node to a well-placed position near its inputs or outputs, and returns the new position for that node. So we don't care about what the actual position is, so we're just gonna move it to a good position. So let's see what this does. And you can see the first node it creates is here, and then the second node is here, and it kind of just moves them diagonally across from each other. Now if I already had nodes in here, so let's do this. Let me show you what happens. It's gonna move it to an odd place. So let's say you have like a whole tree of nodes. Run this again. It's gonna move it to, not always will it do this, but usually it'll try to move it to like the bottom part of your tree, the bottommost part of your tree. And that's fine, I guess. It's not really like ideal. We can remedy that later, but right now let's just keep this going. That's basically how you create nodes inside of here. Now what if you wanted to change the name? Well, you could say wrangle, just call it wrangle. And so instead of attribute wrangle, it could be called wrangle. And now they're wrangle 1, 2, 3, 4. So things like that. Now another way you can move a whole group of nodes. So say you don't want to move everything to a good position. So what we can do is, now toolutils actually has a function called move nodes to good position. And it tells you moves a list of nodes to a good position. So we can actually use this in our thing. Now this requires a list. So what we have to do is we have to construct a list of all these wrangles that we're creating and then feed it into this function. So let's do that. So we're gonna say wrangles is this. This is how you create an empty array with the brackets. And we're gonna, in the for loop, while they're being created, we have a reference to the node that is representing the node that we're creating. So let's use that to construct our wrangles array. So the way you add something to an array, or it's called appending, is by saying wrangles append. And then we can say wrangle. So what we're doing is essentially this is going to return wrangle, the node for wrangle, and then wrangle 1, and then wrangle 2, etc. That's what this wrangles node is, or array, is going to end up being. Let me print out the array to show you. So print wrangles, and let's actually go ahead and move all the nodes to a good position. So I can go ahead and show you that as well. So if I click here, you can see, oh, it's actually moved somewhere different now. That's interesting. Now it's moved up here to the display node. That's wild. And again, we can control that later. Let's say we don't want it going to the top. Let's say you You want the first node maybe to be towards the bottom, and then you want everything like sequentially. So instead of it being diagonal, maybe you want it like right justified, say. So let's do something like that. So what we'll do is we'll delete the wrangles because we don't need that. We don't want this either. And what we can do is we can actually, basically what we want to end up doing is we want to end up creating one wrangle, say here, and then we want to offset each other created wrangle by some certain amount. So that at the end, it's going to look like this. Okay, that's what we're going to try to do. So we know that when we first moved to good position, it made it go here. And that's okay, but we can do something a little bit better. We can do that for the first node, but then for the other sequential nodes, we'll want to do something else. So let's try that. There's another really handy function inside of Python for loops called enumerate. So enumerate, there's actually an enumerate inside of Houdini, and it kind of does the same thing where it, well, I'll show you, but basically it's kind of like saying ID, if you're familiar with this, it's kind of like assigning an ID to the point number. Kind of like that. It's like an index, so to speak. So what we can do, the syntax for that I usually like to do is index, comma, and then the int that is getting incremented, and then you say enumerate at the beginning of the thing, and then a close bracket on the end of it. Now, to show you what this is doing, essentially all this is doing is saying count equals 0. And then at the very end, we're saying count plus equals 1. And then we're using this count elsewhere. That's all it's doing. So if you're in a bind and you don't remember enumerate, that's perfectly fine. You can just do this. This is the same exact thing. Only now we have, or you can call it index, We're going to do it this way, enumerate. And then what we're going to do is we're going to say, okay, for the first wrangle that gets added, we can move it to a good position. So let's do that. So remember when I was talking about arrays earlier, when you want to access the first part of the array, you use this syntax, this bracket syntax, to get the first one. So let's do that. So I'm going to delete both of these, and we're going to say if index, actually in this case we don't need to because it's already provided. So if index is equal to, again, this starts with, oh, actually, you know what? I'm actually not sure how this is going to go. Let's see how this goes. 0. Print true. Let's see what happens. Okay, cool. So it is 0. Even though this is printing 1, the first index of this range will still be 0. Okay, that's interesting. That's good to know. Okay. I had forgotten. I don't normally do ranges this way. That's why. So cool. So that works. So what we're going to say is we're going to say wrangle move to good position. And let's see what that does. Okay, so let's do this. So when we say hello, we get that first wrangle. But where are the other wrangles? If I hit O, you can see, wow, they're way over here. Again, that's because it likes to move everything to the center of wherever it is. So let's control where all these guys are headed. So let's do that. What we can then say, once we move this first one to a good position, let's control the other ones in a different way. So what we can do is we can say, hey, if the index is not equal to 0, another way of saying that is else, we want to do something else. So let's sample this position. Like how would we sample this position right here? Well, if you look at the documentation, there is a position which returns a vector2. Now the vector2 is a little bit complicated, but you can sometimes do the same kind of math sometimes. Thankfully you do have the X and the Y components that you can use, but you can also just use an array of getting it. Anyway, so how do we let's access this position, and equals position, and then let's set it to that position plus a number in X. So let's do that. So we can say wrangle set position, and we can say pose. And actually what we can do is we can go ahead and provide a tuple here. So instead of pose, we can say X, Y plus 3. And let's see. I need to learn how to spell. There we go. And you can see that it worked. So the first wrangle here was created, and then the other ones were laid right on top of it. Now, an easiest way to do this is we can simply multiply the index by this 3 by the index. That's the easiest way to do this. So let's do that. So let's do 3 times the index, because the index is at this point is going to be 1, 2, 3, 4, etc. So let's do that. And now you can see we have created every wrangle. Let's delete all the wrangles. Let's use our new tool that we made, select all by type, and delete. And then we can do the hello thing again. And now we can see the wrangle was created, and then we have all the sequential wrangles created as well. So there you go. That's how we can do that. So this is how you can create nodes with Houdini, just an example. And yeah, I hope this was also informative. And we can also say wrangle set selected to force the newly created nodes to be selected. So we can do that too. Another interesting idea that we can play with to extend this node is, instead of moving the wrangle to a good position where it'll always go to like the bottom part of the tree like this, we can actually play with forcing the node to be created in the center of our network editor, so where we are viewing in our network editor. Now, I'm actually copying this code from my library tool that I built. I had figured this out a while back, so I'm just going to kind of write it here. So the way it works is, let's duplicate this so we don't lose it. So comment this one out, and then here we'll just say set position, and let's write out the new position. So new pose. Let's say it's, so there's a function for the network editor called pose from screen, and then inside of here, let's actually pull this up so you can see. So there's a pose from screen, which, given a position value pose as a vector 2 expressed in screen units, return the equivalent position in network units. So it's kind of like from NDC, I guess. And then there's also the screen bounds we need. It returns the screen space bounds of the network editor. Now, from this bounding rectangle, there's a center which returns the position. So essentially all we're trying to do is get the center of where our visual bounding box area is. So like if this is the minimum, this is the maximum, we just need the center, so like right here. And we're getting the position from screen. So it's kind of like translating screen space to like position space, where we can actually feed it into the node. So we're going to say screen bounds, and then we're going to feed that in the center. So let's just do that. We're going to say new pose here. So instead of this, we are now choosing to do these other 2 lines. So let's see what this does. So I'm going to save it, say hello, and there we go. Now it's pasting it right in the center of our network editor, which is pretty cool. Just wanted to show you guys that. I had to look back on my old code to see how I did it, but yeah, this is a cool way to put the created nodes right in the center of where you're looking in your network editor. All right, now let's create a new tool. This new tool will be kind of like how you can say actions and then you can say create reference copy. This is cool, but in production, a lot of times what you want to do is you want to duplicate it and be able to put it into another geo node. So I want to be able to cut this and I want to be able to put it into another node. But when you do that, because this is relative reference, this is not what we want. This is not good. Breaks everything and it completely ruins the reference transform. So we need a way to convert all these to absolute. So instead of relative path, it needs to be absolute. So how do we do that? Well, let's start by building this tool out. So I'm gonna right click, new tool, put it in my shelf, and I'm gonna say create object copy, and we're gonna say create object copy. And then hit OK, and I'm gonna put it right over here. And we're gonna say, let's actually make a new file. I'm gonna call it create object copy.py, and we're gonna reload it here. So import lib, and you can also say comma who. So let's say import create object copy as coc, and then you can import lib.reload coc, and then we can run a function that we haven't typed out yet, but let's define it now. So create object copy. All right, so that's that. So now we'll say define create object copy and print object copy. Okay, let's just make sure it works. And I'm not going to know because I need to have my shell out open. This is a good time to talk about how to create cool icons for your stuff. So you go to icon, go here, go to HI icon, click on this. Now here you'll see that there's a filter, show files matching whatever. You just delete all this and you just say, so it's related to copy, so you can just say copy star, and you'll get copy. Maybe you like that one, maybe you don't. You just pick one. You pick whatever name you want here. So like if it's related to flipbook, that's why I picked this tool icon for my flipbooking tool, because it's related. So in this case we'll just say copy, and sure, we'll do this. Cool. And this way I can clearly see it and I can identify it and all that cool stuff. So let's object copy, that worked. All right, so let's do this. So let's create a new, let's say nodes is who selected nodes, because you may want more than one node. First we need to import in who, of course. So we have the selected node, so if you select more than one node, it'll do it to all of them. We're going to do a for loop. So for I in nodes, so I is just a temporary placeholder, temporary variable that only is known during the for loop. We're going to get the parent of the selected nodes. So P is I parent, because they may have different, if you're in like split view, for example, you may have different parents per node. So it's important to get the correct parent. So the parent has all nodes have a copy items function, and it needs, this is the best way I found to do this. Let's actually look it up. Copy items. So the nice thing is it has channel reference originals. So we're going to say yes to this, and then relative reference is by default turned on, and we're going to say no to that. So that's the difference. But it needs items, it needs a list. So it kind of tells you can reference it yourself. But copy items needs a list. So we're just going to create the list here. So you can do it like this, like IA for array, and then say I. Or you can just negate that line completely and just feed an immediately constructed array inside the argument itself. You can do it either way. And then we're going to type in those other arguments. So again, to see the copy items, it'll tell you what the options are here. So I'm just going to type it out because I have the code right here. So I'm just going to type it out. So it's channel reference originals equals true, which means it's not going to be relative. It's going to be referencing those channels from the node that you're copying from. So, and then we're going to say relative references, and we're going to say false. So we don't want it to be relative. All right. And now we're going to save, and now we're going to hit OK. So now you can see it says reference from, and now instead of so this is saying reference from transform 1, that's what's in the comment. But this one's saying reference from obj geo1 transform. So this has a different reference. It's actually obj reference. So let's cut this. Let's see if this works. And it does seem to work. So if we edit this, it'll edit, let's make it quick mark by hitting Ctrl 2, and then come back and say Ctrl 1, and now we can hit the number keys on the keyboard to go back and forth between the two different networks. So it looks like it is controlling, or sorry, we can do this one instead. And now you can see, yes, it is controlling everything, and it is working. So that's doing object level transforms. And that's it. That's all you need to do. It's just this right here. That's the next tool I wanted to build. It's very useful in production at least. And thank you. I really hope that this session has really helped you understand tool building inside of Houdini much better with Python. I hope this helps you get a level of grasp that what all you can do with it, the amazing capabilities you now have. And please ask me if you guys have any questions at all. I'm more than happy to answer. And so yeah, just let me know any feedback, negative, positive, whatever. Happy to hear it. Thanks so much for tuning in. Like and subscribe, as everyone seems to say. And I'll catch you guys next time. Thank you so much.